Hi everyone and welcome back. In this video, we're going to talk about the system design of the video recommendation system. In the beginning, we're going to touch base on what kind of systems are out there. We'll talk about the knowledge-based, content-based, collaborative filtering, and two-tower architectures. Then we're going to drill down into more details and talk about how it would represent videos as a vectors. We'll talk about the training of the recommendation models, whether it's a batch and offline training or real-time and online. We'll talk about the specifics of the two-tower architecture recommendation system as well as the ranking. With that, let's get to the video. First, let's talk about what kind of recommendation systems are out there. We're going to start with the most simple one, which is a knowledge-based recommendation system. This is when a user explicitly tells the system what kind of interests one has, and then the system recommends videos based on those interests. For instance, if I sign up for an Instagram and I tell Instagram that I want to watch cat videos, all I'm going to get is just cat videos all day long. The good thing is that I explicitly watch what I want to watch, but the bad part is that there is no intelligence. I can't watch cat videos all day long. One day I'm just going to quit. The second type of recommendation is content-based recommendation. This is a type of system that follows the videos that you are watching and recommends a similar content. Now I don't have to tell my interests to the system. All I do, I just watch videos, and then the system, based on the videos I watch, recommends me a similar videos based on the content. This way, if I change my interest and watch different video, and the system's just going to follow me and start recommending me videos that I've been watching the most recent. This way, there is more adaptive strategy of recommendations, but still the issue here is that I can only watch the videos that I want, and the system recommendation system cannot tell me what kind of videos I might want to watch, but I just don't know about it yet. So there is no intelligence to recommend the videos that I haven't seen just yet, but might want to see them because other users similar to me have seen them and liked them. And this is where collaborative filtering system comes in, where instead of providing recommendations based on the content I watch, it provides me recommendations based on what other people similar to me watched and liked. So what it does, it groups people into a clusters with similar interests based on the watch history, and then provides recommendations based on what other people in your cluster watched and liked. Now, if we combine the content-based and collaborative filtering recommendations, I get two types of recommendations. First, it's based on my own interests and what I watch. And the second one, from collaborative filtering, the recommendation comes what other people similar to me watched and liked. So it just recommended to me because I might like it too. But there is an issue with this approach because if I am a new user and I haven't seen any videos, then there is nothing for me to recommend because it's unknown in what kind of people cluster I would belong. So we would need to come back to the content-based recommendation or knowledge-based. Another issue with this approach is that there is no online training. So there is no way that I watch the video and the big model gets updated. All this information about me watching videos eventually gets trained, maybe every day, as if big batch job, and then gets served to me later. So it's not real-time recommendation. And the last approach is what is the most popular way and what Instagram and a lot of other recommendation systems use. It's a two-tower architecture, which is a very complex system based on the neural networks. And what it does, it splits the recommendation into two different phases. There is a batch training and there is an online training of the models. There are also different stages of the ranking of the recommendation as they get produced from the deep level and make it all the way up to the user. And this is a model that can be updated in the real time, which means that the most recent interest changes or video changes will be reflected in the model and recommendations in the real time. And this is the model that we're going to drill down in this video. Let's look at the recommendation system from the higher level and define the main components and workflow. As you can see on this diagram, it all starts from the left side here, where we have a video corpus of billions of different videos, for instance, as a TikTok or a Instagram. We also have a user at the top that provides some feature data to the system, and we need to provide recommendations or a 10 or 100 videos that the user might want to watch. So first thing first, we need to somehow understand what kind of videos are there, which means create an embedding for every single video. An embedding would contain a features of the video, whether it can be a video frames or transcript or some tags or metadata on the video. We're gonna touch base on this later in the video, but bottom line, the embedding is a list of features that the video has, and they are stored as a vector in our database. And these vectors are used by our machine learning algorithm, which is a neural network algorithm, to train a model that would take those billions of videos and, based on the user interest, it would filter them down to thousands of videos, as you can see on this diagram. Now, once we have thousands of videos that we might want to recommend to this specific user, we need to score them and lower the amount from thousands to hundreds. So we use a completely different algorithm for this and different model, which can be more sophisticated and complicated because we have less data to analyze and filter. So we reduce the amount from thousands to 100, and now we have 100 videos, so we need to rank them. Now we enable our ranking algorithms that we're going to touch base in the end of the video. And it is a multi-stage process until we get a dozen of videos that we want to recommend to our user. Right now, as one just opened up in Instagram, for instance. So this is high level how the recommendation system would need to look like. Now we're going to drill down into the specific components and flesh out more details. Let's start with the most fundamental part. We have a billion different videos, and we want to somehow understand what kind of videos are those, what kind of content they have, tags, description, and how should we treat them, what users we should recommend them. And for that, we have to embed every single video into a one-dimensional or multi-dimensional vector. That vector would be an aggregate of all the features that the video has. And the features can be different types. It can be a video content or a list of frames of the video that we embed. Then it can be a transcript of the video, like what is the video is about. Then it can be a description, tags, and all other metadata that the video has. So as you can see on this picture, for instance, we have a video that we need to embed. And what we do, we just break it down into multiple frames. We embed every single frame of the video, and then we create an aggregate vector from all the frames that we embedded. This way, this video has a unique set of features based on the video content on how it's identified. So that the representation is a representation of the video in the high-level dimension. When I say dimension, I mean the size of the list that will contain the embedding of the video. So this is, for instance, an aggregate embedding of the video content. And then we repeat the same process for the script of the video. For instance, we embed the text, then we embed the metadata, description, tags, and all other parameters of the video. And we probably going to want to have an aggregate vector representation of this video, and we're going to call it an embedding. Now, as we know what embedding is, the process of the indexing videos would look like this. We would have our MP4 or videos in different formats. We extract the frames, we calculate embeddings, we apply the same calculations to the metadata and all other information we have about the video. We store those embeddings in the object storage, and then we index them by storing them in a separate vector database or vector index, a storage that is optimized for vector operations and running a similarity search on the vectors. So if you don't know what that is, go ahead and watch my video on the vector database over here and learn more about it. But bottom line, we take all the videos, index them, store in the vector database. Now, as if indexed our videos, every single video is represented as an embedding, and it's stored in our storage and also indexed in our vector database. Now, if I have a video, I can retrieve a similar videos from the vector database and use them to provide recommendations. As we mentioned before, the key component of the recommendation system is to have a offline and online training, both components working together. This way, the offline training would be responsible for running those heavy jobs across all the videos and finding the new trends, new features of the huge corpus of data. And the online training would be responsible for picking up the recent change of the interest of the user and provide as close as possible recommendation for the user to watch. As you can see on this diagram, for instance, this is a high-level representation on how the online and offline systems can work together. As you can see at the top left corner, we have a user, and the user does two things. First, it performs an action. It's either the click on the video or like or purchasing something based on the media. All these events of actions, they go to the Kafka and then processed by the streaming job. And the second communication is the communication with the model server. This is the server that provides a real-time inference to a user or provides those set of the recommended videos that the user might want to watch. So user provides two types of feedback. The first one is an action, and the second one is additional features based on the recommended videos. And those features are based on the user engagement in the video. Now, as we have the recommended videos, the feedback from those videos that the user watched, and an action that the user probably made, we can create a training example where we can say that watching this specific type of video produced this result. So this would be a data that would be used for the training of our models. And in our cases, you can see these two data types get joined and then thrown into the Kafka cluster, from which we first store it into the HDFS, based on which we're going to do the batch training. And at the same time, all these examples of the data gets consumed by the training worker that is real time. And the training worker, which receives those real-time training examples and fine-tuned the model, that would later on change the weights of the model, and those weights would synchronize, and the real-time model would have the most recent changes based on the user behavior. Also, as you can see at the bottom of the diagram, they have a training parameter servers and serving parameter servers. So these are the servers that hold the weights of the model, and the training parameter servers get updated from both the real-time data and also the batch training of the model. And the serving parameter servers, these are the servers that are responsible for serving those weights in the model in the real time. Now, what is a two-tower architecture in recommendation systems or two-tower neural network? What it means is that we build two different towers. One is for the video embeddings, and the other one is for the user embeddings. So as you can see on this diagram, this is how it works, right? First, at the top, you can see offline, we have all the media that we have in our system. It is called a item tower or video tower, right? This is where all that content gets embedded and stored separately in some media encoding index that probably use k nearest neighbor algorithm to retrieve it from there. And then online side, or the bottom side of it, think about it this way. We have a user that has its own preferences and interests. So what we do, we create an embeddings of the user with all the interests and connections and history on what videos were watched. So what do I mean by saying high dimensional space? Every single embedding of the video or user represented as an array of numbers. And those numbers are location of the vector in the high dimensional space. So to simplify it, if we were to plot a user embedding and video embeddings on a two dimensions, it would look like this. We would have a lot of different movies and a user represented by just two coordinates. But in our case, we have more than two coordinates in our vector array. We have thousands of those dimensions. So all these movies would be represented in a higher dimensional space. But bottom line, as we plot the user on our two-dimensional space over here, we can use a vector search or similarity search or semantic search. It's all mean the same thing, to retrieve the videos that are closest to the user. As a result of it, we get a list of videos that are candidates for recommendation for a specific user. An additional benefit of this approach is that as new videos added to our system, we retrain our model and re-index all those videos offline and then have them available for our online recommendation. Now, as we've talked about the embeddings, the offline, the online models, and how they would serve the recommendations, let's think about how we would rank those results from the models. So as you can see on this diagram, there are two different stages of ranking videos. So the first stage would be more generic. That would return, let's say, 1,000 or up to, let's say, 10,000 different videos that would be applicable for the specific user. For this specific stage, the model has to be pretty lightweight and simple because we need to run it on all the corpus of the videos that we have. So in our case, we can use a simple k nearest neighbors search on our model that was pre-trained based on all the embeddings that we have in the system. So once we have a smaller amount of videos for a user, this is where we can apply a more sophisticated machine learning model that would create a probability score for a person to watch that specific video. And in our case, you would run a multi-label, multitask model that would produce different probabilities for a user to either click on that recommendation or like it or perform different types of actions. So these different probabilities would form a single probability that would be used to recommend, let's say, top 10 or top 20 videos to a user. In the same time, if you ever run different ads on the Instagram, for instance, you know that you can optimize your ad to increase the click probability or a like probability or a engagement probability. So this is how the Instagram ads, for instance, optimize for this specific details, because based on the recommendation, you get a different probabilities for a specific event to happen on that video. And if, for instance, I run my ad and I want to optimize amount of likes on the video, then the model would be optimized to show me the videos that have the highest probability for me to like them, not to click on them, not to comment, but people like. This is why we need a multi-label, multitask model that would have those different probabilities for different actions of the user. Well, we touched based on a lot of different details on the recommendation systems in this video. So there are going to be more videos where I'm going to drill down into more details on the system design and overall design of the recommendation system. But for now, I think you'll find it pretty useful to learn about these main components and architecture pieces. But this is it for this video. I hope you would learn something new today. So if you found it useful, make sure you like and subscribe, and I'll see you in the next video. Bye.